Welcome to our next chapter 9 gravitation video of numericals. Again, in this chapter we will try to complete all the important questions of the chapter, and as you know, before starting the numericals we will first list the formulas that will be used in this chapter. Most of the formulas are related to force. If you know what universal law of gravitation states, then you might be aware of the first formula, which is gravitational force F is equals to gmm upon r square. For example, if the capital M is the mass of the earth and you are on the surface of earth, your mass will be small m. As you know that gravitational force will depend on the product of the masses and inversely proportional to the square of distance between them. Here, if you are standing on the surface of earth, or whatever the object that is on the surface of earth, then what will happen? That particular distance between the object and the center of the earth will become the radius of the earth. Or else we define for generalized term, that is every object in the universe attract every other object with a force which is directly proportional to the square of distance between product of the masses and inversely proportional to square of distance between them. So this will be the generalized formula, and this formula we will use basically when we talk about a planet and an object, so that we can compare easily. Now, another formula that was derived from Newton's second law, instead of acceleration, in this chapter we will talk about objects that are falling vertically downward. Basically, one acceleration will act on it, which is always in vertically downward direction because of force of gravity, that is gravitational acceleration, small g. Here you have seen that the gravitational constant, capital G, has a value 6.67 into 10 raised to minus 11 Newton meter square upon kg square. And this small g has an average value of 9.8 meter per second square. As this small g is acceleration due to gravity, also we can call it as gravitational acceleration. Okay. Also we have one of the formula, small g is equals to capital G, capital M upon r square. Basically, this formula is derived from these two formulas. Okay, let's see. Force was equals to G mm upon r square. Also, it was equals to mg, which was from the second law of motion. If you will compare these two, the mass of the object will be cancelled out. Capital G, capital M, mass of the planet or maybe the bigger object upon r square is equals to G. That's how this small g and capital G are related to each other. Basically, that is the relationship between the gravitational constant and the gravitational acceleration. And as you see that if this gravitational acceleration 9.8 meter per second square, which we take as constant, then the acceleration, or you can say gravitational acceleration, is constant, then we can use equations of motion, which is v is equals to u plus, instead of a we will just write g. So gt will be here gt square and 2gs. Okay, but the thing we have to keep in mind while solving the numericals is sign of g. That is the most important part. For example, if the object, now we will talk about in this chapter, you can say while solving the numericals, we will mostly take examples of objects that are falling vertically downward or they are moving vertically upward, whatever the situation can be there. But the gravitational acceleration has a direction always vertically downward. Now, when to take it positive and when to take it negative. So if you can say object is moving downward, means its velocity is downward, and gravitational acceleration, as we know, also always vertically downward. So we will take g as positive if the situation is like this. Means if gravitational acceleration and velocity has the same direction. Velocity means you can say the direction of motion of an object. But if you throw something upward, so basically the velocity will be upward, but the acceleration due to gravity is always downward. So if the directions are opposite, we will take the gravitational acceleration as negative. Clear? So the sign of gravitational acceleration should be kept in mind while solving any questions related to equations of motion. Coming to the next formula, that is from the previous chapters, that will be useful for solving the examples. Actually, I won't be solving all the solved questions of the textbook. We will solve the unsolved questions. So average speed, that is initial velocity plus final velocity divided by 2, as you all know. Okay, what is weight? Basically, when we say weight, it is nothing but the force of earth that is exerted on us by the earth. So weight is nothing but the force. कितना फोर्स अर्थ अपन पे लगा रहा है या फिर किसी ऑब्जेक्ट पे लगा है, वही उसका क्या हो गया, वेट. सो वेट इज बेसिकली अ फोर्स. कि भाई ये ऑब्जेक्ट नीचे क्यों जा रहा है, उसका ऊपर उसका कुछ फोर्स लग रहा है नीचे से. अब वो फोर्स जिसको अपन ग्रेविटेशनल फोर्स कहते हैं, वही वेट इज इक्वल्स टू मास ऑफ एन ऑब्जेक्ट मल्टीप्लाइड बाय ग्रेविटेशनल acceleration. W is equals to mg, which is similar to this formula. That formula is nothing but the weight when we talk about that particular individual object. Pressure, as you know, whenever we talk about solids and we are concerned about the areas, then we talk about pressure, which is equals to thrust per unit area. What is thrust? If you remember, if you have seen that video of this gravitation chapter 9 in one shot, then I have given you plenty of examples to understand what thrust is. Basically, it is nothing but the perpendicular force, and area you know. So basically, that ratio of perpendicular force per unit area is your pressure. It has so many applications. And the last formula that we can say is of density, which is equals to mass per unit volume. But and you can say that this particular formula we will use somewhat when there is a application of Archimedes principle in the numerical. Okay, so without wasting time, let's start solving the question. Now, whenever we have to find the relationship, we can either take a ratio or we can individually solve the forces for both the cases. Okay, initially we know that the formula of force is G m1 m2 upon r square. Here the distance between two objects is r. Okay, that is your case 1. Now, okay, that will be the answer part. That is only given in the question. We have to calculate the relation, or we have to find the relationship between the two forces, or what will be the ratio or something. We can call this as F1. So in F2, as it is said that if the distance is half, initially if it was r, then it is converted to half. So what will be the force? Apply the formula again. F2 we will call the force between these masses m1 and m2. Again, G m1 m2 as masses are same, but the distance is r by 2 now square. So F2 is equals to, take it as 1, G m1 m2 upon, देखो, r by 2 whole square, r square divided by 4. Okay, now 4 is in the, you can say, denominator, so we can take it to numerator. Okay, so in the next step I will take 4 in numerator. G m1 m2 by r square is nothing but the force F1. So instead of this I can write F1 multiplied by 4. Basically our answer is that the new force will be equal to 4 times the force earlier. So that type of questions are also formed from this chapter. Okay, these questions can also be solved another way, that is by taking the ratios. That's what I'm saying. Initially force was F1 and then the force was F2. Take a ratio directly. Put the values G m1 m2 by r square whole divided by G m1 m2 upon r by 2 square. For simplicity, we will take this into multiplication. Okay, when this goes to multiplication, you know the r by 2 will be upward and G m1 m2 will be the denominator. So like this, I am writing the upper part. Now this denominator will be reversed, r by 2 whole square upon G m1 m2. This method will be easy because as you see, method number 2 is easy because G and G cancel, M1, M2 cancel. Also we can write R square by 4 into 1 upon this R square. See, F1 by F2 is equals to 1 by 4. Take F2 here, multiply 4 with F1. Again I will get F2 is equals to 4 times F1. Basically the new force, which we can say it as F2, is 4 times the force F1. We have another similar question where we need to find the relationship between the new force and the force earlier. Basically there are 3 parts. In the first part it is said that find the force when the mass is doubled, another is the distance is doubled, and the distance is tripled. So we can write m earlier and after 2m as it is doubled. Similar with the distance 2r and 3r. Let's start with the first case. Okay, earlier the force is, we call it as F1. This time I am taking the earlier force as F1 and the new force as F2. I am taking the ratio F2 by F1. You can take the ratio F1 by F2 also. Okay. Now applying the universal law of gravitation, which states G m1 m2 upon r square whole divided by G. Now here they haven't mentioned that which mass is doubled, but any of the mass can be doubled. So if you want, then m1 can also be doubled. m1 changes to, in the new case it's 2m1, so I have to replace it with 2m1. So G m1 m2 by r square, as these are the values for the new force, so I have to write it here 2m1. Again doing the same process, reverse it, flip it, 2G m1 m2 upon r square into this r square will be numerator, and G m1 m2 will be denominator. G m1 m2 cancel, r square cancel, so F2 by F1 will be 2, so F2 is equals to 2F1. So the force will be double. Take a second case. Again we will take F2 by F1. We are taking the new force as F2. So G, in this case the mass is not changing, G m1 m2 as it is, but the distance of the new force is 2r. So I have to write 2r whole square whole divided by G m1 m2 upon r square. So what I will get, F2 by F1 is equals to, if you want you can directly cancel from here, but just to simplify it, 2r whole square will be 4r square into, flip this, will get r square upon G m1 m2. This will be cancelled, this will be cancelled. I will get 1 by 4, which is nothing but F2 is equals to F1 by 4. So the new force will be 1/4 of the initial force. Coming to the last part of the question where the distance between the masses are converted to 3r. Again F2 by F1. Now I am just directly taking this step, G m1 by m2 upon the distance is now 3r. So I will directly write 3r whole square into, initially the force G m1 m2 by r square. What I will get, this G m1 m2 cancel, r square upon, as it is 3r whole square, so don't make a mistake of putting r only or the square of 3 only. 3 square 9, r square, I will get 1 by 9 So this was F2 by F1. F2 will be equals to 1 by 9 F1. That is your new force, which is 1/9 of the initial force. As you can see in the question, mass is 10 kg and the relationship between the forces exerted by moon on an object and the force exerted by earth on an object is related to the force exerted by moon. I have written as Fm is equals to 1/6 by the force exerted by earth on an object as Fe. So 1/6 of Fe is equals to Fm. We have to calculate this Fe and Fm for this mass or object of mass 10 kg. For example, if there is an object of mass 10 kg, what will be the force exerted on earth on that object and what will be the force exerted by moon on that particular same object. Let's see. You know that if I am able to calculate this Fe, then by using this formula I can calculate Fm. But the question arises how to calculate this Fe. If you remember, we have a formula F is equals to m g. Whenever there is any object of any mass which is on the surface of earth, because of earth's gravitational force, we can use the formula F is equals to mg. That is because of earth. Fe is equals to mass given at 10 kg. Now the confusion arises that what will be the value of g I will take. I already told you that constant g we will take as 9.8 meter per second square. In few cases you can take 10 meter per second square, but as of now, as of your class, most probably you have to use 9.8 only. You can take 10 also, but then your answer will be mismatched. So go with the 9.8 only. Okay, 10 multiplied by 9.8 will be 98 Newton. So force exerted by earth on an object of mass 10 kg is 98 Newton. Let's check the same, the force on मून कि भाई यही 10 kg के ऑब्जेक्ट को अगर आप मून पे ले जाओ तो मून कितना फोर्स लगाएगा उस पे. So we just have to put the value 1/6 of Fe, 1/6, and Fe we have got 98. So 98 by 6. We can cancel 2 3s are 2 4s are 2 9s are. You'll get 49 by 3. If you want to get the decimal value, that is 3 1s are 3, 3 6s are 18.10, 3 3s are 9, so 16.33, and the forces are in Newton. So I will, the same object of mass 10 kg will have a force on exerted by moon on the same object will be 16.33. See the change. I hope you are able to write what is given in the question. You remember the rule that you have to write what is given, what you need to find out, and the formula that we will use to solve the questions. Okay, if not, then you can watch the video. Initial velocity is given as 49 meter per second, and as you can see, we have to calculate the maximum height. Let's try to find out the concept. When an object is moving upward, you know that after some time it will reach a maximum height, but when it reaches a maximum height, at that time, for a fraction of second, its velocity is 0, and then it will come back to the ground. Clear? So to calculate the maximum height, but whenever it will reach the maximum height, its velocity will be 0. So that's why the velocity I have taken as 0 meter per second. So we have to calculate that maximum height, h max. Basically we have to go with the displacement formula and then the total time कि भाई यहाँ से ऊपर गया, ऊपर से नीचे आया, total time कितना लगा. Okay. And if the object is going vertically upward, so the velocity is in vertically upward direction, but we know that the direction of gravitational acceleration is always vertically downward, so the directions are opposite. That's why we have to take the gravitational acceleration as negative. The value you know, 9.8 meter per second square, but in this case when it is moving from here to here in the upward direction, we have to take the gravitational acceleration as negative. You know the reason now. Okay. So if the gravitational acceleration is there and it is constant, we will go with the equation of motion. So I think we can use second equation, s is equals to ut plus half at square. But to calculate s in that particular equation, I will need time t, and there is no data related to t is given. So we have to find the t first. So for that I will use the formula v is equals to u plus at. Final velocity will be 0 for this particular case. Initial velocity given as 49. Acceleration we will take minus 9.8. Okay, that will be the gravitational acceleration here, and time we need to calculate. This minus 9.8 t, when comes this side, 9.8 t will be positive. So t is equals to 49 divided by 9.8, or 49 divided by 98 into 10. 9.8 by 10, 10 will be 10 when goes in numerator. Okay, what I can say, 49 2s are, so I will get t as 10 by 2, means the time to reach the maximum height is 5 seconds. Okay, this is the time to reach the maximum height. Remember, it's not the time that the ball takes from here to here and here to here. This time will be useful for calculating displacement. S is equals to ut plus half at square. Now I have all the values: initial velocity, acceleration, so gravitational acceleration, and time. Putting the values, 49 I think the third equation will be easy to calculate, so we will go with the third equation. By using these also you can calculate the answer, but third will be more easier. V square minus u square is equals to 2g s. S will be equals to v square minus u square upon 2g. Final velocity is 0. Initial velocity is 49. Whole square 2 into minus 9.8. Okay, here I will get minus 49 square, which is 49 into 49, upon minus 2 into 9.8, which is equals to 98 by 10, and 10 when goes to the numerator like this. 2 5s are 49 2s are. So I will get displacement as minus minus cancelled, 49 into 5 divided by 2. Compulsorily we have to divide it only. 9 5 are 45, 4 carry, 5 4 are 20, plus 4 2, 45 by 2. 2 1s are 2, 2 2s are 4, again 2 2s are 4.5 meter. That will be the maximum height, you can see, of that particular object, 122.5 meter. But what about the total time? As if it is reaching here in a time 5 seconds, then basically that is 5 seconds, and another downward journey will also be of 5 seconds. So total flight will be 5 plus 5. So the answer is 10 seconds. So basically, initial velocity in the downward direction is 0 meter per second. As you can see, the word released, which means there is a free fall. So initial velocity is 0. The displacement, or you can say the height, is given as 16.6 meter, and when it will reach the ground, just before that, what will be its velocity? So we have to calculate the final velocity. As you can see, both velocity, or you can say the motion, and the gravitational acceleration in the same direction. That's why we will take g as positive 9.8 meter per second square. Now think about the equation of motion where we can relate all these things. Can we go with v is equals to u plus at? No, I will need time there. If we want to calculate v, then s is equals to ut plus half at square half gt square. There also we cannot calculate velocity. V square minus u square is equals to 2s, the third equation of motion, which is v square minus u square is equals to 2 gravitational acceleration g and s. V we need to calculate initial velocity 0 to gravitational acceleration positive 9.8 and s is 19.6. V square is equals to, as you know, 9.8 into 2 will be nothing but 19.6 only. So I can write 19.6 into 19.6, which is 19.6 whole square. So v square is 19.6 whole square. So v will be 19.6. So the final velocity will be 19.6 meter per second. Jumping to the next question, in which the initial velocity in the vertically upward direction is 40 meter per second, and as you see, gravitational acceleration always downward, so we have to take it as negative as the directions are opposite. Three things we need to calculate. First is the maximum height, the net displacement, and the distance. Okay, let's try to calculate each of the thing. First is maximum height. How I will calculate the maximum height? As you know, whenever an object will reach a maximum height, its velocity will be 0. So to calculate that, we can use s is equals to ut plus half at square. I will need time there. V is equals to u plus at, cannot calculate. We will go with again third equation of motion, v square minus u square is equals to 2s. 2 instead of a, this will be g. And instead of s, we can also write h max, because we are taking a case where we are talking about the object when it reaches a maximum height. Displacement itself will be a maximum height in the first case. Velocity, final velocity 0, initial velocity 40, so 40 square, 2 gravitational acceleration negative 9.8, and we have to calculate h max. Put at h max subject maximum height, you will get minus 40 into 40 upon minus 2 into 9.8. Minus minus cancel, 2 20s are, we will get 20 into 40 upon 98 divided by 10, which will be in the numerator. So again we can do like this, 20s are, 2 4s are, 2 9s are. I will get 4,000 basically upon, on calculating we will get a value 81.63 meter. This will be the maximum height. The second part, we have to calculate net displacement. Now see, if it reaches a maximum height which is of 81.63 meter, so from ground he start, the initial point is ground, and he reach here where its velocity becomes 0, but then he take a U-turn, again reaches the ground. So the initial and final points are same, so the net displacement will be 0. Also you can say if the displacement is positive, then the displacement will be negative in the downward journey, which will be minus 81.63, again plus 81.63, minus 81.63. On getting the net displacement will be 0. The last part was calculate the distance, total distance. Okay. So to get the total distance, as you can see, in the first journey it was 81.63. In the journey downward, it will be 81.63. Why? Because when we talk about distance, we talk about the actual path. If the direction changes, doesn't matter. So the distance will be 81.63 plus again 81.63. You will get 163.26 meter. That will be the total distance. We have a very interesting questions. It says the height of tower as 100 meter. One object from the top moving downward and one object from the ground moving upward. Now, at some point of time, they will meet, but both these processes, the object that is moving downward and the object that is moving upward, the forces, you can say the action was simultaneous. Keep in mind the action was simultaneous. What does it mean? At the same time. ये ऑब्जेक्ट जब ऊपर से नीचे आ रहा था उसी टाइम पे इसी ऑब्जेक्ट को हमने नीचे से ऊपर फेंका. अब किसी एक टाइम पे वो मीट करेंगे. जिस टाइम पे वो मीट करेंगे, that time we have to calculate, and the displacement or distance from the ground or from the top, whatever it is. Initial velocity for the upward object will be 0, or initial velocity of the downward object will be 25 meter per second. जब फ्री फॉल कर रहा है उसमें तो इनिशियल वेलोसिटी कुछ चाहिए नहीं, बिकॉज ऑफ ग्रेविटेशनल एक्सेलरेशन इट विल मूव डाउनवर्ड. किसी चीज को नीचे से ऊपर थ्रो करना है तो कुछ तो वेलोसिटी होगी इनिशियल. दैट्स व्हाई दिस पर्टिकुलर ऑब्जेक्ट विल हैव अ वेलोसिटी u2 एंड दिस विल हैव अ वेलोसिटी u1. अब समझो, यहाँ पे जो दिया है अपन को 100 मीटर, जब भी वो मीट करेंगे, एक ने इतना डिस्टेंस ट्रैवल किया होगा, दूसरे ने यहाँ से इतना. अगर किसी एक को मैं x लूं, ऊपर से नीचे आ रहा है उसके लिए मैं x डिस्टेंस लूं, तो दूसरा क्या होगा? सी द टोटल इज 100. अगर एक को x लूं तो दूसरे को मैं क्या लूं कि मुझे टोटल 100 मिले? तो आई विल टेक 100 माइनस x. करो x प्लस 100 माइनस x, x कैंसिल, टोटल 100 मिल गया. तो दैट इज द लॉजिक दैट वी विल यूज इन दिस क्वेश्चन. ये लॉजिक यूज नहीं करोगे क्वेश्चन सॉल्व नहीं होगा. दो केस बनेंगे. Let's take both the cases. एक तो ये वाला ऊपर से नीचे आ रहा है, एक तो नीचे से ऊपर जा रहा है. चलो, जो ऊपर से नीचे आ रहा है ऑब्जेक्ट, ग्रेविटेशनल एक्सेलरेशन इज आल्सो डाउनवर्ड, so we can take it as positive. Think about which formula we can use. H is given, so we can go with S is equals to, or yes, S is equals to ut plus half gt square. Instead of S, I will use x. Okay. Initial velocity was 0 plus half. Gravitation acceleration is, as it is not written, we will write 9.8 meter per second square. 9.8, and time is t square. As we need to calculate the time. So what I got, x is equals to 9.8 by 2, which will be 2 4s are 8, 2 9s are 18, 4.9 t square. Now we will use this. We will use this equation. Don't worry. In the second case, where the object is moving upward with some velocity u2, which is 25 meter per second. So the velocity is a direction vertically upward and the gravitational acceleration vertically downward, so we will take gravitational acceleration negative. Again, taking the same equation, S is equals to ut plus half gt square, but the displacement is this 100 minus x is equals to initial velocity 25 time t plus half. G will be negative 9.8 meter per second square, so I will take minus 9.8 t square as it is. If I put this value of x here, 100 minus, as I got the value of x from the equation 1 as 4.9 t square, I will write 4.9 t square here, which will be equals to 25t minus 99.8 by 2 t square. 100 minus 4.9 t square is equals to 25t. This will be 9.8 by 2 will be nothing but 4.9 only. This will be 4.9 only. T square. 4.9 t square, 4.9 t square cancel. We will get 100 by 25 as t. So t will be equals to 25 4 is 4 seconds. So the time is 4 seconds. ऑब्जेक्ट को ऊपर से नीचे आने में और नीचे से ऊपर जाने में दोनों में टाइम क्या लग रहा है? 4 सेकेंड. Coming to the next, that is distance. We also need to calculate. You can put the value of t in any of the equation. Let's put it in the first 4.9 and t is 4. So x will be equals to 4.9 into 4 for the 16. On multiplying, I will get 78.4 meter. So the time when they meet will be 4 seconds, and the distance from the ground, as okay, that particular distance x was from the top of the tower. From the top of the tower it was 78.4. If you want, you can also calculate from the ground, which will be 100 minus x. So 100 minus 78.4 will be the distance from the ground. You just have to subtract it from 100. So we have a mass 50 gram, and the volume here, v is not the velocity, okay? The volume is 20 centimeter cube. Density of water is given as 1 gram per centimeter cube. So we don't have to convert this into kg and this into meter cube. Okay, as we have to compare it with density of water only, which is in gram per centimeter cube. So to check the particular object will sink or float, we have to calculate the density of that particular object. Then I will tell you will it sink or float. Basically, density will be equals to mass of that object upon volume of that object. Mass of the object is 50 gram upon volume is 20 centimeter cube. 5 by 2, 2 to 4, 2.5. Unit will be gram per centimeter cube. You can just put the units here, respective units. You will get the density of object. Also you can call it as rho as 2.5 gram per centimeter cube. Now, if the density of object is greater than density of water, then it sinks. That is the condition. And if the density of object is less than density of water, then it floats on the surface of water. Okay, check. Density of water is given as 1 gram, and we got the density of object as 2.5. So the density of object is greater than density of water, which means the object will sink. That's how you can check the object will sink or float. Another very important question you can say, where the total time is given. Basically, it was thrown with some velocity, it reaches some height, then it comes back to the ground. It has some initial velocity, but the total time is given. So when it reaches the maximum height, its velocity will be 0, that is for sure, but the time will be 3 seconds. 3 सेकेंड ऊपर जाने में, 3 सेकेंड नीचे जाने में, as the gravitational acceleration is 9.8 meter per second square acting continuously. What we have to calculate? The initial velocity with which it was thrown, the maximum height. Okay, whenever it will reach a maximum height, the velocity will be 0 at that time, and the object has covered 3 seconds. We have to calculate the displacement at 4 seconds. Let's start with part A. To calculate initial velocity. Okay. If we think about initial velocity, can we start with v is equals to u plus gt, as v is there, u, g and t all is yes. So we can start v is equals to u plus gt. But initial velocity is direction vertically upwards. V is 0. Initial velocity u plus g minus 9.8, and time will be 3 seconds. I will get u is equals to 9.8 into 3. U will be 29.4 meter per second. That will be the value of initial velocity. Second is B. We need to find maximum height. When it will reach the maximum height, as you see, the velocity will be 0. And by using that case only, we have calculated initial velocity. Can we use s is equals to ut plus half at square? Yes. Can we use v square minus u square is equals to 2as? V, u also there. That also we can use. So v square minus u square is equals to 2gs. So when it will reach the maximum height, let's call it as h max. What can we say about the gravitational acceleration? As it is moving upward, again it will be negative. 0 minus initial velocity is, we have calculated as 29.4 whole square is equals to 2 minus 9.8 h max. So we will get h max is equals to minus 29.4 into 29.4 divided by minus 2 into 9.8. 2 minus minus cancel. On solving, we will get maximum height as 44.1 meter. Now the last part is again to calculate the height when it is at 4 seconds. So as you can see, when it reaches the 3rd second, it has a velocity 0. So imagine a situation when the object was moving from here to here somewhere. So in 1 second, total will be the 4 seconds, but here its velocity was 0. If this is the situation, when we start the observation, so initial velocity is 0 for this case from here to here, and the time when it reaches the particular position is 1 second. Okay, from the top. So again we can use, s is equals to ut plus half gt square. Here I will take the displacement. Okay, we have to calculate the displacement. Initial velocity as 0 plus half 9.8. This time I will take it as positive. Velocity downward direction, and the gravitation acceleration also in the same direction, and the time 4 seconds. No, we won't take 4 seconds because it takes time from here to here as 1 second only. S will be equals to 9.8 by 2. 2 4s are 2 9s are. The answer will be 4.9 meter. So our answer will be 4.9 meter. Thank you for watching the video. We will meet in the next video solving some more important numericals. Until then, goodbye.
Physics works.